And Khan did this nicely. So exponentials, y equals exponentials, exponentials. So y equals e to the x, y equals 5 to the x, y equals 18.35 to the x, y equals 3 to the x. All these are exponential functions. Exponential, the x is in the exponent. That's it. That's what we mean. Exponential functions, the x is in the exponent. That's all we mean. So let's see how this would look on a graph. I'll do y equals 3x, kind of a little bit easier to graph than y equals e to the x, because we don't really know the values of e squared off the top of our head. 3 to the x is a little bit easier. Shape will be the same. So x, y. So if x is 1, 3 to the first power is 3. If x is 2, 3 squared is 9. If x is 3, 3 squared is 3 cubed is 27. And I could keep on going.
That's pretty simple.
So here's x equals 1, y equals 1, 2, 3. X equals 2, 4, 5, 6, 7, 8, 9. And 3 is way up here at 27. Yeah, so I would consider all these like parent functions, yeah. Now if I plug in 0 for x, 3 to the 0 power, anything to the 0 power we discussed, day 1 is 1 of course. So when x is 0, y is 1. So now we've got this part of the graph going really fast, going up really fast, very steep. What happens here when x is a negative number? Let's find out. X is negative 1. 3 to the negative 1 power.
1/3.
Very good.
0.3.
Yeah, 0.3 repeating. So when x is negative 1, y is 0.3. That's right there. When x is negative 2, I have 3 to the negative 2.
That's that
1/9. So it's right there, and I'm starting to see the pattern now. So why can't this graph go into quadrant 3? Why can't this graph go into quadrant 3? Marcus, what do you think?
Because no matter what we plug in for x, it will never equal 0.
Why is that, Marcus? You're right. Why? Say a little more.
Because you can't get, because no matter like if you plug in 0, it equals 1.
Right.
So you can't get any smaller.
What if I plug in? No, hold up.
No.
I can get smaller than 1. We did that. We got 1/3. We got 1/9.
You can't get closer than that though. Like you can't get closer to anything because it will always keep going.
So, but it keeps getting closer to 0.
But it will never touch.
Why is that? Why? Why can't it ever equal 0?
You're continuing to divide. You're not dividing by 0.
We're getting a little closer. Jennifer, what do you think?
Because it has the asymptote.
Right, so it definitely has an asymptote here. I agree. Say that again? So what about the exponent, Nora? So the exponent could be 0, right? Like I could plug in 0 here. What do you? Right, and why is this? Why is that? I just want to push. I'm going to really push to get this why. Why is it that I can't put a number here to make this be 0? Why? Why not? Rambir, why not?
Isn't it just that it can never reach into the negatives? Because the 3 is a positive?
That's true, so it certainly can't go negative, but why can't it be 0? Why can't it be 0, Nora? We'll come to Janaea.
There's no number times itself that would ever equal 0 except for 0.
Right. This is the key. There's no number that I can ever multiply by itself to get 0. Even if I did...
0.
Right? Unless it's 0. Unless it's 0. Right? So, we have a horizontal asymptote at y equals 0. So the domain here is all real numbers. And the range here is 0 to infinity. 0 to infinity.
That's a
Question?
beast point.
I think so.
No, for me.
For you, Marcus?
I got it.
Should I just assign the whole card, Marcus? Be done with it right now?
Because I got it going.
All right, let's come back to this board. I'm just gonna do one homework problem now. What's up? 4 minutes or 9 minutes? 4? Oh boy, here we go.
You can do it.
Okay, let's do number 5 on the front. Number 5 on the front. And this is why we're gonna spend the whole day tomorrow practicing. This is why a whole day tomorrow is practicing. No new material. We are working at a fast pace so that we can build in these days of just practice.
That's why we should watch Con.
That's right. So y equals negative 6 times 0.5 to the negative x plus 4. Khan did this type of problem beautifully.
Which one are you working?
Number 5.
Okay.
Khan did this beautifully. Step 1. If you're trying to graph this, start by plugging in 0 for x. That's the easiest thing to do. If x is 0, 0.5 to the negative 0. Negative 0 is just 0. 0.5 to the 0 power is 1.
I don't see that.
Victoria, can you help Marcus find that? 1 times negative 6 is negative 6.
Oh, you didn't put MX.
Right, but y. So negative 6 plus 4 is negative 2. So when x is 0, y is negative 2. 1, 2, 0, negative 2. Now what about, another question? So negative 1 times 0 is 0. 0.5 to 0 power is 1. 1 times negative 6 is negative 6. Plus 4 is negative 2. Does that work? Okay. Now let's plug in a really big number. A really big number. Let's plug in 100. See what happens. Y equals negative 6 times 0.5 to the negative 100. It's negative because we already have the minus sign there. Plus 4. I'm going to work through this so I can bring the exponent downstairs and make it positive. I'm going to need people to really stay with me for the last 2 minutes as we push through this. So I have negative 6 divided by 0.5 to the 100 plus 4. Y equals negative 6. 0.5 to the 100 power. That means 0.5 times 0.5 times 0.5. Do that 100 times. I'm going to get a really small number.
Very, very cool.
If I did 0.5 times 0.5, I got 0.25. Times 0.5 again, 0.125. Times 0.5 again, 0.0625. We're getting small really fast. So it's negative 6 divided by a small number plus 4. If I have negative 6 divided by a super small number, I basically have negative infinity. Basically. It's negative 6 divided by a number that is so small. Try it on a calculator. If you do negative 6 divided by 0.000000001 on your calculator, you'll get a huge number that is close to negative infinity. The number is really close to negative infinity. Negative infinity plus 4, the 4 does nothing. The 4 does nothing. It's so small compared to negative infinity. So y equals negative infinity. So when I plugged in 100, y was basically going to negative infinity. So when I plug in 100 for x, y is coming downhill to infinity. Questions on that? The logic. Nora? I mean, so you don't need to put a point. Did I say to identify some points? Yes, you don't need to worry about the point, just the shape. Okay, sit with me for 1 second. What if I plug in negative 100? Y equals negative 6 times 0.5 to negative 100, which is positive 100, plus 4. Y equals negative 6 times a small number. 0.5 to 100 is super small. We just talked about y. Plus 4. Negative 6 times a super small number is basically about 0. This sign means about. It's about 0. Negative 6 times a super small number is basically 0. Plus 4. So y basically equals 4. So when x is negative 100, y is 4. And here's our asymptote. The asymptote moved up 4 spots. Why? Because there's a vertical shift up by 4. The asymptote's originally at y equals 0. It shifts up by 4. 55 minutes tomorrow to practice this. Watch the Khan videos tonight. We'll kill this tomorrow. Have a great day, guys. Awesome job.